All right, so I think we shall start. My name is Mateusz Wosiński. Hello, everyone. I'm a senior data scientist in deepsense AI. I've been working here for more than a year now. I'm a graduate of applied maths at Lodz University of Technology, but pretty soon after finishing my studies, I switched to the computer science, to the IT world. And as a result, I've been working with machine learning models and data science for quite some time now. And today I would like to tell you a little bit about building applications powered by large language models, so very hot topic currently, using LangChain library, which gets enormous recognition recently. So let's begin with the agenda of today's meeting. After a short introduction, I will present the use case. So the application called Niffler that we built with my colleagues from deepsense AI during the last couple of weeks. It serves for extracting knowledge from documents. I will show you a live demo of this solution. Then I will move to the LangChain framework. I will begin with the overview of this library, and then I will move to the more detailed explanation of its components. And finally, we'll have a short summary. So please leave the questions for the end of the presentation. All right, so without further ado, let's dive into the talk. So the question you might ask is, why even did we start working with LLMs? I'm pretty sure that everybody listening to this talk knows what large language models are. But for the sake of completeness of this presentation, a couple of words about ChatGPT, the most prominent example of those models by ChatGPT, so by itself. ChatGPT is a large language model developed by OpenAI. It is based on the GPT 3.5 architecture. It was designed to understand and generate human-like language. It can operate in different languages, can answer almost any question that you ask it. And its main purpose is to assist and provide helpful information to its users. As I'm pretty sure that everybody of you already experimented with this model. It's super powerful, super impressive. And if you want to know more about this family of models, we had already a deep talk on this topic by Artur Zegadło. It's called AI Revolution with Large Language Models, and you can find it on YouTube. So feel free to check this out. And the question I already asked, why did we even start building our app? Well, we believe that those large language models will transform the daily work in general, but especially the daily work of us developers. And we wanted to answer if we can create something useful with those LLMs. We wanted to get to know what is the easiest way to develop solutions with them. How can those models transform the most tedious part of work? Do we need a lot of work on our side to develop solutions with those models? We wanted to know if we can instruct LLMs to behave in some certain ways easily, and if we can avoid most common issues like hallucination, like creating fake facts, fake news, etc. Did we manage to do that? Let's find out. So let's move to the use case, to the application called Niffler that we built in deepsense. And a couple of assumptions that we had on the beginning. So we imagined that we can have a document in almost any format. We took PDFs and TXT for the start, and we want to find an answer to a question which can be found in any fragment of this document. Of course, we want to get the answer as fast as possible. And what is very important for us, we want the evidence and that this answer is in fact inside a document. Last but not least, we want to ensure privacy and security of the user. And here you can see a screenshot from our application. This is a chat with our agent, let's say. And here we ask two questions about ibuprofen. One, how long can we store this medicine? And the other, if it is allowed to take it during pregnancy. And as you can see, the answers are pretty decent, are pretty clear, but if there is an evidence for them. Now let's move to the demo to show you real examples, maybe not real, but just to show you that it works in real time. So here we can see a tab called Documents, and we have a couple of documents already indexed. They are in different formats, in TXT and in PDF. And as you can notice, every document has 3 keywords connected to it. Those are tags which were produced also by large language model during indexing process. So let's first start with some text document, maybe not ibuprofen, but this one. This is about unemployment in Germany, as you can see. We used an open source data set from 2014, so it's not up-to-date data. And it is about unemployment in Germany, as I said. This data set is called BBC News. So let's ask the question, what is the unemployment rate in Germany? And we expect that the answer will be based on the document, not on the knowledge gained by this model. It shouldn't be up to date. It should be somewhere inside the document. We got the answer that this rate is equal to 11.7%. So let's click here. And here we can see the fragments of document underlined. Here we can see that the unemployment rate is 12.6, so it's a bit higher. But when we move to the other part underlined, we can see that the adjusted for seasonal changes, the overall unemployment is 11.7, so the number that was answered by the model. So it works pretty nice. So let's ask another question. Maybe who is the Chancellor of Germany? As this information is also somewhere inside a document. And of course, it will be based on the document, so it will not be up to date. The answer is that the Chancellor is Gerhard Schröder. And we can see that, in fact, in 2004, I think, Gerhard Schröder was a Chancellor of Germany. So maybe not now ask a question that is not connected to those keywords, a question that is not about Germany or unemployment. So who is the Prime Minister of Poland? And we expect that this question cannot be asked based on this document. So we should get something like, I don't know, answer from Niffler. Let's see if this will happen. Yes, it answered that it's not sure, and it is tuned to answer questions about unemployment, Germany. And this question validation is also performed with a large language model, which is quite interesting. Apart from this demo app, we worked on experimental application as well. It was developed with Streamlit library, just to demonstrate features in more iterative way, to conduct different experiments. And here we worked on a couple of more functionalities like multi-document question answering. So looking for an answer not in a single document, but in a set of documents. Then we worked on extending agent knowledge with a Bing search. And we experimented with support for CSV files. And we have also a demo, this time in form of video. So let me open it. I will just increase the quality. So we should click on multi-doc support. Here I selected a folder. This folder contains various judgments from Indian trials. And it is also open source data set with PDFs. And I want to find a case which involves police sub-inspector. So I wrote it down. We have to wait for a second. And we have the answer in a natural language produced by large language model, which is pretty okay. The case involved a police sub-inspector who was dismissed from service after the superintendent of police initiated a departmental inquiry against him. And now we can go to this particular file as we have a source here. And now we can ask questions only about this file. And here I wanted to ask what were the parties of this trial. So now we only look for the answer in this particular document, and we get pretty okay answer. The parties of the trial were State of Madhya Pradesh and the respondent Shardul Singh. And we have other tabs: last answer context and last answer citation. The first of them shows us the fragments of the document that the answer of large language model was based on. Those are pretty long. And in the last answer citation, we can see exact fragments that contains this information. This time about trials, the parties of the trial. So here we can see the superintendent of police initiated a departmental inquiry against the respondent who was a sub-inspector with respect to certain charges. So the answer is on point. We have evidence here. And now I wanted to ask about something current, something up to date. So I asked about what is the current exchange rate from Indian rupee to USD dollar. And because this document is not about rupee, it cannot be answered. So we click on extend knowledge and it calls a big search with exactly this phrase. And we get the answer that 1 Indian rupiah is worth 12 thousandths of dollar. And as we can see here in Google search, it is in fact the correct answer. All right, so let's move back to the presentation. Okay. Yeah, so now let's focus on LangChain. And what makes it so cool. We'll start with the overview of this library. LangChain is a framework for developing applications powered by language models. And the two main assumptions made by its authors were to make make this framework data-aware, so to allow developers to connect a language model to various sources of data, like PDFs, docs, whatever. And second, to be agentic, so to allow a large language model to interact with environment, with user, and perform certain actions based on observations and based on their input. LangChain provides a couple of useful functionalities. First of all, for loading data, it supports multiple data formats, multiple kinds of indexes, which can be used with different embedding functions and can be used for retrieval of the most relevant documents. It provides LLMs and prompts, so the modules for prompt management, prompt optimization, and it provides generic interfaces for large language models. It also provides chains, so the sequences of calls instead of single calls to those large language models. And finally, there are agents which allow LLMs to make decisions on their own about what actions they should take after seeing a certain observation, and to repeat those actions until the goal is accomplished. We have also a couple of statistics about LangChain, which make it even more impressive. So this framework raised already $10 million in seed funding. It had around 150 releases in around 6 months. In fact, I updated this value yesterday, and I saw today on Twitter it is already 149. So the pace is just amazing. It has around 30,000 stars on GitHub, more than 50,000 followers on Twitter. There were about 350 contributors, and it is not only implemented in Python, but also in TypeScript. All right, and now we can dive into more details. I will explain you particular components of this framework. And these are just modular abstractions that allow us to work with language models with more ease. So first of all, there are documents. The document is the abstraction, main abstraction for storing data. Every document contains two fields. First of them is page contents, so the text from the document chunk. And here I will stop for a second. You probably know that large language model cannot process very long documents, as there are certain limitations on number of tokens it can process. So we have to split the document into smaller chunks. And that's why every document contains text from the chunk. And the second field is metadata, so all additional information about the document. For example, it can be its path, its author, maybe summary, some tags, keywords, whatever we want. And for this operation of splitting documents into chunks, LangChain provides various modules. There are more than 10 for doing this, and we can list here modules like character text splitter, latex text splitter, TikToken text splitter, and there are many more. So let's move to loading data. LangChain provides many document loaders, which are responsible for loading data into this document format. For now, there are more than 50 loaders, quite a big number. And there are loaders, for example, for different cloud providers. And so for Azure Blob Storage, Google File Storage, and S3, so the Amazon storage. Then we have loaders for more standard formats like CSVs, Word docs, PDFs, and TXT files. There is also unstructured file loader. This is based on the library of the same name. It's very popular and it allows processing of multiple data formats. There are more exotic data formats like Hacker News, Notion databases, and YouTube. And we have a very useful loader, which is called directory loader, that allows us to use whatever file loader we want to load all the files discovered in the selected directory. And in this snippet of code, you can see the CSV file loaded into document format. This is a single CSV file, but it is split into multiple documents. As for every row of this file, we have a separate document. And as you can see, for every column, we have first a name, like here is team, here is team, here is team. And then we have a value from the row corresponding to this column, so that the large language model would understand what this value is about. While working on Niffler, we had a couple of issues with loading data. To be more exact, it was with loading PDFs, as the loader implemented in LangChain has some limitations. The most important one is that it does not provide bounding boxes of the loaded text. So we had to address it on our own using PDF miner package. One of my colleagues, Michał, implemented this loader, added some magic of his own for joining regions, and now we can annotate the fragments of PDF which contain the answer for the question that we ask to our agent. And the second limitation is that this loader cannot read the drawings. As this is a more complex task, it requires some OCR tools, and we left it for the future due to the high difficulty of the task. Let's move on to the next component. Now we have indexes. They help us to store documents in the way that allow large language models to interact with them. Indexes store embeddings of chunks produced by models, and they store also documents content. The most common usage of them is retrieval of the most relevant documents. We can perform various standard operations on them, like saving, loading, updating, or merging. And there are more than 10 available implementations in LangChain, like Files, Elasticsearch, or Chroma, very popular indexes. And here we can see a diagram. We have a document that we have to split into chunks. We have to initialize a large language model and calculate embeddings for every chunk, which will be stored then in the index and ready to use. And here we can see what it looks like in code. It's very easy. First of all, we have to import the selected loader. We pass the path to the file to this loader, and finally load this document. Then we initiate text splitter and split this document into chunks. And we also define the embedding functions. And here we create our index using from documents method and passing those loaded documents and embeddings function. And now we can run a similarity search on this index using a query, so a string, and we get the result, so the fragments of the document that are most similar to this particular query. So as you can see, it's very easy. It's a couple of lines of code, and you can work with index from the beginning. Then we have models. LangChain provides a standard interface, which helps us to interact with a variety of LLMs. There are already integrations with more than 20 LLM providers. Of course, there is integration with OpenAI, but also with Hugging Face or less known Model and Aleph Alpha and many more. And there are various text embeddings models as well, also from OpenAI, but also from Azure, Hugging Face, or TensorFlow. And once again, we have a snippet of code. You just have to define your LLM. Here it's add a model, and you can start querying it this time for telling a joke. And in the next fragment of code, we can see how embeddings work. So we define an embedding function. We provide a text in form of string, and we can run a method either on a single string or on a list of strings. So once again, it's very easy. Let's move on to custom models. LangChain allows us to create a wrapper for custom large language models. It only requires one method, the call method. So if any provider launches his model, or if we want to use our own model, there is no problem to switch the implementation. And the same goes with embeddings. We just need to define the hardware, the pipeline, and inference function, and we can self-host embedding function to avoid any, let's say, security or privacy issues. Let's proceed to another component. This time, these are prompts. So you probably know that working with language models is quite different than working with standard code, as we can instruct the model how it should behave, and those instructions are called prompts. Prompts are usually combinations of a template, so a reproducible way to generate a prompt. We may add some examples which should improve the performance of the model, and the input from the user, so the information which will be taken into consideration by the model while generating its output. And here we can see how such a template is built. So we provide an f-string, a template, Here we want the model to act as a naming consultant for new companies. We provide some examples of a product like search engine and good name for it, like Google. And here we ask a model what is a good name for a company that makes product, which will be input from the user. Another component which will use those prompts are chains. Chains allow us to combine multiple components together. And the most basic and common example is to take the input from the user, format it with a prompt template, as I just shown, and pass it through a large language model. And here on the snippet, you can see how it is done. We define the large language model. We define a prompt template. Here it is much shorter. It's just what is a good name for a company that makes a product, and this will be an input from the user. We initiate a chain, LLM chain. We pass a large language model and this prompt, and we run it on input, this time colorful socks, and we get the name rainbow threads, which is pretty nice. The next step is sequential chain, and it allows us to make a series of calls instead of just one single call. This is useful when we want to take output of one chain as an input to another one. Here we can see an example that the second prompt is to write a catchphrase for the following company, and we pass this name that was just produced. And we have to use a module called a class called simple sequential chain. We pass here two chains and run it once again on colorful socks product. And here we can see how it works. First of all, it creates a name, cheerful toes, once again, very nice. And the catchphrase, spread smiles from your toes. I think it worked quite well. Let's move on to the chains in Niffler. We used a couple of chains, actually. We used pre-built chains, which are implemented in LangChain for things like summarization, question answering, and chat with question answering. And also we implemented some own chains for things like tagging, for question validation and answer citation. And here you can see what it looks like. We have a template. We tell a model that it is a chat validator. Its job is to verify if question is about any of the following topics, and it is input from another chain. Those are these keywords that I mentioned during the demo. And you are given question, say yes if question is related to any of those topics, otherwise say no. And we provide also this question. This is the input to this chain. And we just repeat this code that I just showed on the previous slide. So we initiate LLM chain with model and with the prompt. All right, let's move on to the last component, the agents. As sometimes the action cannot be predefined, it's dependent on the input, on the observation. And LangChain allows us to create an agent which has access to different tools. And depending on input, it can decide which tool should be used. And the actions of the agent will be repeated until the goal is reached. LangChain provides 7 built-in agents for now, for CSV files, for JSON files, for pandas, for SQL, Python, and 2 more. I don't remember now what are the 2 remaining. And it's worth mentioning that also it implements React framework, basically. And here we can see a snippet for a CSV agent. It's extremely easy to initialize such an agent. We just provide large language model and the path to the CSV file, and we run a question which can be answered with this document, with this file. What's the square root of the average age? And now the agent processes this question. It has a thought that it needs to calculate the average age first. So it produces the pandas formula. It calculates the average age, and now after performing that, it should calculate the square root. Once again, it produces the pandas formula, but notices that math library is not defined. So first it imports this package and now repeats the previous formula and gets the final answer, and has also the thought that the process is finished and it knows the final answer. So it's pretty impressive, at least for me. All right, so that will be it about components. We can move to the summary of the presentation. So first of all, Niffler, we built an intelligent assistant powered by large language models, which was developed using LangChain. It's an interactive document explorer, which can summarize documents, which can tag those documents with keywords. We can chat with the agent, and it provides a citation for the answers given. And we also prototyped more features like extracting information from multiple documents and extending agent knowledge with the up-to-date information. And in terms of LangChain, this is the framework for developing applications powered by language models. It provides different components, so the abstractions which are necessary to work with LLMs, such as data loaders, indexes, prompts, chains, and agents. I explained them in high level, I would say, but you saw the snippets of code, so you now know how easy it is with LangChain. It provides use case specific chains and agents, for example, CSV agent, summarization chain, or question answering chain. And it's this framework is developed and getting recognized in an enormous pace. Yeah, I recommend you to follow this library, as for sure more great functionalities will appear pretty soon. All right, that will be it from my side. Thank you for the attention and see you next time.